Hi, welcome to this lesson on number patterns, geometric sequences. Solving a geometric sequence problem, question 1. We're given the following sequence, 2, 6, 18, 54, and so on. Our goal is to determine the general term and find the 20th term of the sequence. Okay, so let's have a look. Let's check that this is a geometric sequence. So firstly, the first thing I do that comes to my mind is I need to write out what the general term looks like. So it's a times r to the power n minus 1, where n is a natural number, and that denotes the nth term in the sequence. So my constant ratio r, if I take the ratio of the fourth term to the third term, that's 54 divided by 18, which is 3. And I can check that the ratio of the third term with the second term, 18 divided by 6, that's also 3. If I even check 6 divided by 2, that's also 3. So our constant ratio appears to be 3 in this case. Our first term a is given as 2. So now I can therefore say that t sub n is equal to 2 times 3 raised to the power n minus 1, where n is a natural number. Alright, so that is the general term of this sequence. And you can check if you plug in values for n, you'll get the right term. So the third term should be 18. So if I plug in 3 for n, I get 2 times 3 raised to the power 3 minus 1, which is 2 times 3 squared. Well, 3 squared is 9. Notice how I act the exponent onto the base only, not onto the first term. And 2 times 9 is 18, which is what we expected. So therefore, the 20th term, t sub 20, is going to be 2 times 3 to the power 20 minus 1. Sure, that's going to be quite a large number, right? So it's going to be 2 times 3 to the power 19. So we are probably going to need a calculator to solve that one. So let's bring our calculator down. So it's going to be 2, open brackets, 3, close brackets, raised to the power 19. Sure, quite a large number. So let's write it down and see how we read it. So 2, 3, 2, 4, 2, 3, 2, 4, 5, 2, 2, 9, 3, 4. Okay. So just as a recap how we read numbers, I start from the units position and then I go every 3 decimal places to usually get the units position that I'm in. So that's hundreds, that's thousands. So you can sort of think that after this little comma here that I put here, just to indicate, I'm not actually putting a comma there, but I'm just indicating that there's the thousands region. Then 1, 2, 3 more. Now I'm in the 100,000 region. 1, 2, 3 more. Now I'm in the million region. And if I'm just one more left of that, I'm in the billion region. So this is the billion. This is the 100 million. 100 million. This is the 100,000s. And this is the thousands. So how do I read this monstrosity of a number? Well, it is read as 2,324,522,934. All right, and that is the 20th term of the sequence. That is quite large, and there's actually a little caveat to this. If you look at the general term of the geometric sequence, it looks something quite familiar to us. There's an exponent here. So that means that this term is growing at an exponential rate. So that is why it is growing so fast, or sometimes growing slow, depending on the value of r. All right, and that is the solution to this problem. I'll see you in the next one.